If you're a Roblox developer, you might have come across this video. It's a great video, by the way. I would highly recommend watching it. Basically, it talks about how they made their FPS game 10 times faster by eliminating lag from projectiles. I mean, they're firing 1400 bullets per second with zero visible lag. It gives a very broad overview of how they simulated projectiles in their game, but it doesn't really get into how projectile simulation actually works, why it optimizes your game, what it even means to simulate a projectile, what it means for the bullets to be fake when you can clearly see the bullets, or how to go about implementing it into your own game. The goal of this video, the one that I'm making, is to answer all of those questions, give you a technical overview of how projectile simulation works, provide my own implementation, so by the end of the video, you will come out with a genuine understanding of how projectile simulation works and why it reduces lag. Additionally, as a byproduct, you will have a better understanding of various Roblox tools and systems like remote events and replication, and you will come out a better, more knowledgeable Roblox developer. Before we talk about how to simulate projectiles, let's take a step back and talk about projectiles. And before we talk about projectiles, let's take another step back and talk about how things move in Roblox. So let's say we have a game. The game is made up of clients and a server. In our case, we have 3 clients, and the client is basically the same thing as a player. So we have John, Jane, and Bob as our players, and we have one server. A client is basically a player's computer. So John's client is basically John's computer. The server is also a computer, but it's Roblox's computer. It's owned by Roblox, okay? Also, pretend these shaded rectangles represent the player's avatars. So this blue shaded rectangle represents John's avatar. And same for Jane and Bob. Note that all the avatars are in this thing called a workspace. The workspace is basically where 3D objects live in a Roblox game. Let's say John wants to move from point A to point B, okay? If John wants to do that, John's client has to tell the server, hey, I want to move from point A to point B. Let's assume the server says this is a valid move, okay? Then the server will also move John's avatar from point A to point B. When this happens, the server will tell everyone else that John moved from point A to point B. So the server will tell Jane Bob's avatar moved. The server will also tell Bob that John's avatar moved. It might also tell John again that his avatar moved. Not totally sure about this one, but the point is, when the server moves something in the workspace, it tells everyone else the same thing. And then it'll tell them to move their version of the thing in their workspace. This process is known as replication, okay? Because when one change happens, same change is copied to all the other clients. Now these arrows represent network calls. Remember that I said each client is a computer. A computer is a physical thing in the real world. Different computers communicate with each other through network calls. These computers could be anywhere. Let's say the server is in California. John could be in New York. Jane could be in Texas. And Bob could be in, I don't know, London. Generally, computers are far apart, which means network calls can take a relatively long time to reach the recipient. Furthermore, everyone is connected to the internet, and each computer has a limit to how much data it can upload and receive from the internet. Because of this, network calls are generally an expensive operation. When you're thinking about optimizing your game, it's important to optimize your network calls. It means both reducing the number of network calls you make and reducing the size of the data that you send in these network calls. Now, you'll notice that just from singular move, John moving his avatar from point A to point B, this made multiple network calls happen. Let's say John wants to move in a straight line. Let's just pretend that's 5 new positions in 1 second. In that case, John will have to make something like 5 different network calls in 1 second, and the server will receive all these and also send 5 different network calls in the same time, also in a second, give or take. Now take this example with a grain of salt because I believe Roblox has its own optimizations for things like moving in a straight line. But the point is, when you move frequently in a game, that will result in frequent network calls. So now that I kind of showed you how replication works and the cost of replication, we can start talking about projectiles. Maybe you can already see where projectiles become a problem. Okay, so what is a projectile? For now, we'll just say a projectile is just another object that moves. Now, what do we mean by a real projectile as opposed to a simulated projectile? All that really means is the projectile exists in the server's workspace. Okay, so let's say this game is an FPS game, and John has a gun and wants to fire a bullet from his gun. So John is holding his gun and he clicks, right? That tells the server that he wants to fire a bullet. And again, let's assume that this is a valid move. Using real projectiles, the server will create the bullet in its workspace. And because there is a change in the server's workspace, this change will get replicated to all the clients, just like before. The server will tell John, okay, I created the bullet. The server will also tell everyone else that John has fired a bullet from his gun. So far, this is nothing new. This is the same thing I explained before. Okay? Also, just like before, the bullet is going to move, typically in a straight line for each new position that the bullet takes on. It's going to require another network call. So let's say the bullet is moving kind of fast. It takes on 10 new positions in a second. That is going to result in 10 more network calls, right? Because with each change in the server's workspace, it will get replicated to all clients. Each time a replication happens, that's done through a network call. Now let's go even further and say John is using a machine gun, so John's firing 10 bullets per second. Let's say each bullet is the same speed and will also take on 10 positions in a second. That's going to multiply this by 10. So in a second, just from John's gun, we're getting 10 times 10, 100 network calls per second. Once again, Roblox probably has some kind of optimization for this in the backend, so the actual number might be less, but the point is, we're making a lot of network calls. That's expensive. I should have moved these bullets, but yeah. We haven't even considered yet what the other players are doing. Each other player could also have a machine gun and is also firing a lot of bullets at any given time. So right now we have 3 players in our game, but in your game you probably have a lot more, maybe 20 players, maybe even 30. So all this is going to get multiplied, and the end result is that a very large number of network calls are being made because the projectiles are being created and moved in the server's workspace. And this will make your game very laggy because each player will not have enough network bandwidth or something like that. It will not have the capacity to send and receive all of these network calls. And if you go watch that video I mentioned earlier that should be linked in the description, you'll see just how much this can actually lag your game. I believe they show off firing over 1,000 projectiles in a second, and you could visibly see how slow the game was. Okay, so this is what happens when you do real projectiles, which means projectiles that live in the server's workspace. So how can we optimize this? Well, the vast majority of the network calls from using real projectiles came from replicating each new position of the projectile as it moved. If a projectile is moving like this, on your screen it looks like moving continuously. It's taking on many different positions throughout different points in time. And for each new position, a network call had to be made to tell the clients that this is where the bullet is now. That's where most of the network calls came from, because we were moving the bullet in the server's workspace. Well, wouldn't it be nice if we could just not have the bullet in the server's workspace and still get the same behavior? Well, that's what I'm going to show you how to do. So what is a projectile? Well, a projectile can be reduced to a couple of values. A projectile has a position, which means where it is in space. It has a direction. It has a speed. It has a 3D instance, which is basically it's visual, what the projectile looks like. And this is kind of the same thing as its size. Now we'll just say this is what a bullet is made of. Now, if you recall, the purpose of a workspace is to store where 3D objects live. Well, the server doesn't really care what a bullet looks like. Only the players care about what a bullet looks like. So for now, let's change the 3D instance to the size, because the server still needs to know the size of a projectile to determine when it hits someone. And now, see, a projectile is reduced to position, direction, speed, and size. Well, now that we don't have a 3D instance anymore, then the projectile doesn't need to use the workspace. So let's actually get rid of this stuff. Right now the server doesn't care about the workspace. What can we do now? Well, instead, now we can have this. When the server is initialized, we can have a table or a list of current projectiles. Oh, a projectile also kind of needs type projectile, which means, is the projectile a bullet? Is it a arrow? Is it a fireball? That's what that means. We'll have a table of current projectiles where it'll basically keep track of each projectile and most of these data points. So what happens when John wants to fire a bullet? Well, John still has to tell that to the server. Okay, maybe I got rid of the workspace too early, but the server still has a workspace. We're just not illustrating it here. But basically, when the server receives this, the server can create a new entry, projectile 1, and when we create a projectile, we have to give it a position, which is roughly wherever John's avatar is. Let's say it's here. We have to give it a direction, which John will probably communicate through this network call. Say this, and it's going to need to know the type. I'll explain why we need the type and not anything else in this table. So John wants to fire a bullet. This is all we need because everything else is kind of constant. The speed of a bullet is a constant, and the size of a bullet is a constant. That is the same throughout all space and time. Because of this, we will also give clients this knowledge of these properties of a bullet. We'll give it its speed, and we'll give it its 3D instance, which is the same as what does the bullet look like. We'll put this in replicated storage because all clients can have access to replicated storage. So now, when the server creates this entry in the table, we can send a message back to the client, to all clients, that a projectile of type bullet was created at this position and traveling in this direction. Okay? And when a client receives this information, we'll make the client create the bullet. A client knows what a bullet looks like because we gave them access to its 3D instance in replicated storage. And the rest of the information, the position, direction, and type, it'll be communicated through this network call. Okay, so each client does this. Now, all we did was create the bullet. If you'll notice, the same number of network calls happened with the previous approach using real projectiles, right? When John wanted to fire a bullet with real projectiles, the same process happened. John told the server that he wanted to create a bullet, and the server responded that John created a bullet. So right now, we don't really see the advantage of using this approach. The value of this approach here is when we move the bullet. The thing about typical projectiles is that they move in a deterministic way. Their movement is predictable. Their positions are predictable. So this might not work if you have some kind of honing missile or something like that. But if you just have a bullet that moves in a straight line, it doesn't even have to be in a straight line. It can be affected by gravity. But if the movement of your projectile is predictable, then we will get value from this approach. So let's say the bullet is moving at some speed. In every frame, the server will calculate the bullet's new position. Let's just say its next position will be at 2, 4, 3. Which kind of makes sense because we had this as the direction. So only this number would change. So let's say the bullet's new position is 243. Well, how will the clients know that this is the bullet's new position? We don't want to send another network call for this update, because if we did, we would be creating the same problem that happens with real projectiles. Well, since the bullet's path is deterministic, we can just have the client calculate where the bullet will be in the next frame. So the client knows that a bullet moves at this speed. The client already knows the bullet's position because the bullet already exists in the client's workspace. And assume we'll also have the client keep track of the bullet's direction. Well, then the client can calculate itself where the bullet will be in the next frame. So now the server knows that the bullet moves, and the client also moved the bullet. And notice that we did not make any new network calls for this movement. In fact, we will never have to make new network calls just for the movement of the bullet. We will have to make a new one when the bullet hits something, but I'll get into that later. But so far, for the entire lifetime of the bullet, before it hit something, we only had to make 1 or 2 rounds of network calls, depending on how you interpret this. We made a fixed number of network calls. Only for the bullet's creation, and we didn't have to make any network calls to update the position of the bullet. That is the advantage of using this approach, and that's why I called it serverless, because the physical bullet does not exist in the server's workspace. It's only these data points. Now, if you're comparing any two solutions in software, there's going to be advantages and drawbacks. Clearly, the advantage of this approach was that we greatly reduced the number of network calls necessary for a projectile. The drawback is we offloaded some of the projectile calculations onto the client. So now the client has to do the work of calculating where this object is. So we optimized network calls, but we made the clients do a little more computational work. But in the grand scheme of things, this is absolutely a worthwhile trade to make, because making hundreds or thousands of network calls per second is a lot worse than doing this type of calculation on the player's computer locally. Okay, that's the essence of this approach, simulating projectiles. Okay, so how do we handle projectile hits? Well, if we actually had a 3D object on the server, we would do something like listen to the object's touched event, right? But in our case, we don't have the projectile instance on the server. All we have is this data right here. Well, we can use something called ray casting. But actually, in this example, I'm going to use sphere casting, which is the same thing, but more general than ray casting. So let's say this represents this position in space. This point is at this position. This is not a physical object, this is just this location. What sphere casting does is, given point, we simulate a sphere around it, and then we can send the sphere in a direction. In our case, we kind of just want to keep the sphere at the point, or maybe just send it a little ahead that the projectile is traveling in. But when we sphere cast, the Roblox engine will tell us if this simulated sphere hits something. We can use that to detect when our simulated projectile hits something. Also, this is where we would use the size property, because we have to specify how big we want our sphere to be. This will be done on the server. So what we can do is, for each frame in the server, we can do 2 things. First, we'll do a sphere cast to see if our existing projectiles hit anything. And if that happens, we'll fire a network call or remote event to the clients, telling them that this projectile 1, hit something. And then the clients will handle that. We'll write code on the clients to handle that. We'll also do any hit logic on the server. So if projectile is supposed to damage players, then we'll do that here when we detect a hit. If there is no hit detected, according to the specified properties, we'll just keep moving the projectile based on the specified properties. So each frame, we go through all of our current projectiles. We'll first check if it hits anything, and if it doesn't, then we'll move it. Now, how should the client handle this hit event? Well, all we kind of have to do is delete the corresponding projectile. So each client will also have a table of projectiles, because the clients have to know which projectile ID maps to which object, because generally there's going to be multiple different projectiles at any given point in time. And if the server detects that projectile number 1 was hit, we have to tell the client to delete projectile 1. And like I said, the server will handle the damaged logic. Another thing to consider is setting a maximum lifetime for each projectile. So let's say we don't want any bullet to exist for more than 10 seconds. It's pretty simple to do that, as I'll show you later, but we basically do the same thing. So now we can do this. In each frame in the server, we first check if the bullet has lived for longer than max lifetime. If yes, then we can send the same event as when projectile hits something, right? Because it tells the client to destroy the bullets. And then we'll do the other stuff. If the bullet has not expired yet, then we'll check for it if it hit anything. If it didn't hit anything, then we'll just move the bullet. Now we've covered the entire possible life cycle of a bullet. So in the entire life cycle of any given projectile, we only fire 2 to 3 network calls. The entire life cycle of any projectile. And that is my way of doing projectile simulation. And I'll show you the actual performance gains. Before I start demoing the projectiles, let me demo a little bit all the stuff I was saying about replication from just moving your Roblox avatar. I'm going to spawn in my character, and you can see my avatar is in the workspace. All the physical objects, including the fireball, the wall, everything, all the 3D stuff is in the workspace. Now I can do Command Shift F3. That'll turn on the network summary. In particular, let's pay attention to out data. The second number here is packets per second. The packet is basically the unit for network calls. And the third number is the average size of the packet. Right now you can see I'm just standing still. I'm moving a little bit from my character's animation, but animations are done locally on the client, so that does not use any network. Okay? I'm standing still and we're getting an average of around 30 packets per second and I don't know, 25 bytes as the average packet size. Now, if I start moving around, due to how replication works, these numbers should start jumping up. So I start moving around, and immediately the packets per second jumps to 40, 50, 60, and the size jumps to around 40 bytes per packet. And if I stand still again, it jumps back down to 30, around 30 and 25. Yeah, and just keep these numbers in mind because I'm going to show you these numbers again when I start firing projectiles. Okay, so now for projectiles, I have this wand here and I already have the code for shooting a fireball when I click while I'm holding this wand. Shoot fireball, it jumps to 40, 50 packets per second. Shoot another one, do the same thing. That's sort of around the same packet size as when I was just moving my character. So if I just do this, shoot a bunch of them, well, we're hitting 80 packets per second now. Almost 100 even. And look at the average size. We're getting around 500 bytes average packet size. So this is using a lot of networking resources. Let me show you the difference when I turn on simulation using simulated projectiles. Let me just look at the difference. Just look at that. The packets per second is basically not changing from when I was just standing still. It did not even go above 40. Okay? The average size is not even hitting 30. And this is what you get when you simulate projectiles. But I just want to show you the difference, how much simulation optimizes your networking costs. Okay, y'all, that was basically it for the video. Hope you learned something. So since this is my first video on the channel, if you are a more senior Roblox dev watching this, and you want to make any corrections to what I just said, please put them in the comments. I've only been developing for a little under a year. Also, please give me feedback on this video style. I don't think I've seen other creators do whiteboard style technical explanations of Roblox systems. So yeah, let me know what you think about that, or just any part of this video style. Give me ideas for other videos I should make. Let me know if you want me to make a video about something you want to see, yeah, give me video ideas. If you did learn something, or if you enjoyed the video, consider subscribing to me. Yeah, hopefully I can make some money off of this channel. This video was kind of a lot of work too, so you can show your thanks that way. Alright, peace.